dividends at 0, then it's easier, but it could be a dividend number too. Okay? Anyone, any had a question about Blackscholes, or you want me to go through an example of Blackscholes? Can we go through a Blackscholes example?
You don't mind?
Yeah?
I mean, if you don't want to,
Okay.
I agree as well.
So you can bring your notes ready to do the exam. Okay. Actually, do I have a Blackscholes here? Actually, I didn't create one. Actually, I didn't do one. I don't have an example. But if you go to the spreadsheets, I can bring a spreadsheet, I guess. Actually, believe me, I didn't print one. No, I do have one. So just using the spreadsheet I have on my Excel already on my. So you're gonna have a sigma. It's another one of those things that will work. Just give it to the next professor or get frustrated. Okay. So you're gonna have a sigma. I don't like that either. So you get a sigma 0.5, you get a T, half a year, quarter of a year, 3 months. You get the risk rate, 0.1, 10%. You got your stock price, 100. You got your exercise price, 95. You just give it a yield 0. Okay? That's what you need to build the Blackscholes. First, you're going to build a D1. D1 is ln Sx divided by x plus I minus delta plus sigma squared times t divided by sigma times t. D2 equals sigma divided t minus D1. So, ln 100 divided by 95 plus I 0.1 minus 0 plus variance 0.5 squared divided by 2 times 0.25 times divided by 0.5 squared D1. Now, just to give you a tip, never ever, even if you're the best Excel guy, I don't even do it. Do not try to build this whole thing in one cell. Too many parentheses, too many divisions here. If you do a parenthesis, you have to do another parenthesis in here. You know how it works. It's very difficult to run this massive. And you're going to be off and you're going to be screaming. So what I do, I just break it up into different cells. I do that first. So I'm going to a separate cell on a white paper on the side, and I'm going to do equal ln, and then I'm going to do 100 divided by 95, and press enter. And we'll give you a number. And then you do this part. Easy. 50 squared, blah, blah, blah. You do this, you do that. And then you do this part. Let's call this A, let's call this B, let's call this C, and then you do A plus B divided by C, and you get your D1. Okay? So once I do that, I get D1, I get 0.43017. Okay? That's D1. D2 is this part, which you already have in your C column, minus 0.4307, so that's 0.1817. 0.517. Let's do 5 decimals. Doesn't matter, because Excel will do it. Then you normalized D1. Now in Excel, when you normalize, this is the formula. I don't want you to ask me this question in the exam because I've been doing it for years and always somebody's asking me, could you give me the Excel formula for normalizing? I won't give it to you. Write it down now, forever, okay? Because there's a lot of is norms. Important is the S, dist, normal distribution. Open parenthesis and you put in the number, 0.43017, and you enter, and I will give you 0.66647. And then you do, that's D1. Normalize D1. 6.667. Normalize D2, which you're going to equal norms as D, which is N. Normalize 0.18017. If you equal enter, will give you 057149. So you got your D1 and D2. You got your other numbers, and you do your S is 100 times, this is delta is 0, E equals 1, yeah.
How do you do E in Excel?
It's equal EXP,
1.
and then you put in the minus delta in a parenthesis. Okay? You know that if you do ln delta t, you know, that's the E in the delta t power. But it's a natural logarithm. It's a reverse natural logarithm, but don't worry about that part. So ln, by the way, it's Excel 2 is equal ln. That's the formula in Excel. Okay? And exp, exponential, delta times t. Okay? Not in the power. Never do that. It's in the parenthesis exp. Excel knows it's the power of e. Okay? So you do this. This is 0, 0 e in the 1 power. It should be 1. And 0.66647 minus 95. Now this thing, you're going to do the same thing. IT, I is 0.1 times 0.25 minus, and once I do it, I think it comes out to 0.9997 something. I don't know. I don't have it here, but the calculator will do it. And ND2 is 0.57149. So 66 times 100, $66.64 minus this whole thing will give you like a 52 something. 52 something. So the C should be $13.70. Okay. Any questions? On a put option, you can do the D1 and D2 the same, except the formula here is reversed. The put option formula for Excel, for Blackscholes. I'm going to have the formulas too anyway. You have the formulas. It's X EIT times 1 minus ND2 minus S E delta T times 1 minus ND1. since you have everything, all the numbers, you got this number, 0.66, so 0.57149, 0.6641, and minus that, so the reverse. This is 33%, sorry, this is 43%, this is 33% or less. Because the put call parity, 66% chance the S will go up, 33% is going to come down. The same thing we did on the binomial pricing model. That's what it means, this whole thing. You normalize it on a table. Where is the stock going to do it? So the 67% will stay in here, and there is 33% is going to be outside those boxes. That's what the normalization is, normal distribution, right? Okay. Any questions on question 3 of section 1? So that's a 10-point one. Okay. Okay. Then we go to section 2. Section 2, question 1, but I'm not going to call it question 1, I'm going to question 4. So section 2, question 4. Section 2 deals with futures and forwards and swaps. Future forward swaps. And it's 50 points. So 30 plus 50, and then the FRH is 20 points. Section 3 is the smallest because there's not much that I taught you there. So question 4, sorry, and then you have the question 9. So I think it's 4, sorry, put it back. 40 points, 30, 40, 20, and then 10 points for this take-home question. Okay, which I'm gonna have it here, everybody's gonna get a question. Question 9.
So this question's worth 40 points then?
Yeah, section 2 is 40 points. Sorry, I forgot 10 points more. So 30 points, section 1, 40 points, section 2, 20 points, section 3, and then the take-home question at the end will be 10 points. So that's 100 points. Okay, okay, let's go to the question 4. By the way, I updated the formulas. It was a quick error on futures forwards on the mark-to-market. I fixed that. So everything is fixed there. Everything is there, should be fixed. Okay, so I'm going to give you one of the sheets I gave you. You know, futures, agricultural futures, precious metals, indices, stuff like that. Okay, and I'm going to ask you questions from there. I'm going to have like basically some distributor of gold or distributor of cotton or corn, whatever, is planning to sell. So as a distributor, you want to sell. And he's trying to sell at some date in the future. Of course, the date has to match the futures exchange. And then I'm going to ask you to, this is an easy one. He wants to sell. And in order to sell, he's afraid that the price fluctuation might hurt his feasibility on his revenue. Since he's selling, he's getting paid for what he's selling. If it's a cotton, he sells cotton, so he wants to have a feasibility in the revenue in the future. So he will go into the market and short, right? Short cotton. If you sell, you short as a hedging mechanism. So you're going to do a hedging exercise. Okay? Now, there are 2 types of hedges that I taught you. One is a full hedge. So you're going to buy all the contracts possible. Or if I give you the standard deviation of each of the derivative and the underlying asset and the correlation between the two, you're gonna use the optimum hedging. The optimum hedging, right? Which is H, sorry. And you're gonna do the S times correlation. So I'm gonna give that number that, you come up with the percentage, you're gonna multiply by how many contracts are closed in the, how many contracts. Okay? For example, if there's an independent distributor of cotton is trying to sell, let's say, 1 million pounds of cotton, 3 months. So if you look at the sheet I'm going to give you, how many contracts for cotton is 50,000 pounds per contract. So if it's a million divided by 50,000, you will be a fully hedged contract. But if I give you that on optimization, whatever the number is, let's say this number is 0.65. You only have to multiply the amount of contracts to fully cover the hedging times 65%. So you don't have to fully 100% of your contracts. If you have 1 million cotton pounds you're going to sell, but each contract is 50,000, you're not going to do 1 million divided by 50,000, which is 20 contracts. You're going to do 20 contracts times 65%. So that number is going to be much lower. That number is going to be 13, for example. 13 contracts and you'll be good to go. Okay? Everybody got that? I have an example in my, I think it's example 6 of that little sheet I gave you. Okay? So that's, but I'm going to continue with the same question, and I'm going to say, okay, why don't you do a fully hedged? Yeah, fully hedged or optimum. If it's fully hedged, in a fully hedged, I would say if the spot price of cotton goes up by $5, it goes down $5, you want to show all the scenarios. And that's on question 4, I think. Problem 4. Okay, that's one of the questions. Question 4. I want to ask you mark to market. That's fine. That's a boring thing anyway. It's not anything. But I will give you actually an agricultural precious metals futures, and you have to do this exercise. It's about 15 points, this one, because it might be a dual question. Okay. And question 5. It's going to be a swap, interest rate swap. Now, when you do interest swaps, I want you to print all my spreadsheets. There is a simple, it could be a simple interest rate swap, which is, you got to build your Excel sheet with the cash flows. I'm going to give you the forward contracts, and it will be a time 1, 2, 3, 4, and then the forward contract for a LIBOR rate. And I'm going to say, okay, you have a notional amount, a fixed rate, and then you're going to switch from a LIBOR to fixed. So you got to try to run the present value to find out which one is the best given the forward rates. That would be a simple interest rate swap. Okay? It's in my Excel sheet. Right here. Okay. Right here, it's you swap here. You can actually go to the video. So this is the simple swap. And the next question could be an interest rate swap between two companies. One company has given the option to do fixed floating, another company fixed floating. They have different views. You get the opposite view of what to do. You get a swap rate, and you figure out how much money they're going to save by actually doing the swap. I have that on Excel. It's exactly the same thing right here. Okay. So it could be a simple interest rate swap with cash flows and IRRs. So basically it could be an IRR, could be a present value. Just print this page and bring it with you. You have to calculate those 3-4 spreadsheets. I'm gonna be a little vague on this. I don't want to say exactly because that's easy, right? So I want you to understand how swaps work and things like that. So simple currency swap, it's a bunch of them. So simple currency swaps, different ideas. It could be something like that that shows the simple currency swap with the two things. So interest rate swap or currency swap. Currency swap when you have a euro versus dollar or some other country. I have the exact spreadsheet for currency swap. So it could be two questions in that section for swaps. So we're going to question 5 and 6. Okay? So question 5 could be a currency swap. Question 6 would be an interest rate swap. One could be simple, or it could be the two companies thing. So that we're done with section. We're done with section 2. Any questions on that? Okay. Then section 3 will be FRAs and IROs. It will be one FRA. Now, probably question 7 now, right? Section 3. It's probably the most difficult question of all the exam, except the ones that you're going to take home. Because I will give you the FRA, which is one big formula, which you can miss the formula. But what makes it difficult is that you have to use Blackscholes, this is the thinking comes in, to value the premium. On an IRO. So FRA is going to be straightforward. The IRO is the most difficult one, sorry. So the IRO will be a difficult question because you have to find a premium on the IRO for the swap. So it's basically an FRA with an IRO type option. Remember, FRA doesn't have options. You got to buy the future. You got to get into a forward agreement, rate agreement, and you will get that rate. You fix the rate now, and you will get the rate about the LIBOR rate, either 90 days or 180 days. You're going to get that rate money to the point. IRO, you pay a premium now to get the IRA in the future. So if I give you those numbers, you have to put into a Blackscholes. I'm going to give you the sigma for sure, standard deviation, interest rates moving, and things like that. Okay. I have an example like that in my spreadsheet. So you should look for that. Let me see if I can be a little more specific. So let me get into the FRA. Let's do an example FRA so you can see what I'm talking about. The FRA is going to be something like that. It's going to be a little table. This is the FRA question. I'm going to have a 90-day LIBOR. I'm going to have the LIBOR rates, let's say 6, 6.5%, 7, 7.5%, 8, 8.5%, 9, whatever. Okay? I'm going to give you a rate given. Now, rate given could be, I could say rate given for 30 days, 60 days, 90 days. There will be a different rate here. So let's say 7%, 7.25, 7.5% or something like that. So if I want to do a 30-day rate given, you're only going to use a 7% here. And then you use a formula to calculate the actual notional amount. I'm going to give you some notional amount, let's say $30 million. So now you're going to calculate the actual FRA for any given formula, and you know that big formula I just give you to calculate the FRA. And I have that actually posted on my website. So you're going to do the 7%, 6% with a differential. You're going to start negative, positives, that kind of thing. Okay? And you're going to calculate profit and loss. Okay, that's an easy 10 points. And question 8, I guess, will be the one that's difficult. There, actually, I'm going to give you an IRO, okay, with a notional amount, actually what a loan is. I'm going to give you the 90-day LIBOR, whatever. And then now, my question is, calculate the fair annual rate premium. What will be the actual premium to pay given the forward rates? Okay. So I'm going to give you that. Of course, you're going to have a 30-day LIBOR and 30 days plus 90 days. Remember, the IRO has the 120-day days. On the book, you find a lot of calculations like that. So you can use some of the IROs in the book, or you can use my Excel sheet. So once you determine the 30-day and the 120-day LIBOR, I'm going to give the two. You're going to start building your Blackscholes. I'm going to give you standard deviation for sure, and I'm going to give you. I'm going to say the standard deviation for a 90-day LIBOR, let's say, is 0.3 or something. The exercise rate for the call option is 7%. That's the X. And it has a 30 days until expiration. I'm going to give you an I. Actually, what's interesting, don't confuse the I on the rate. I on the rate, actually. And then assume the natural log. I'm going to give you then you have to put in your ln divided by sx, the stuff that we learn on Excel. And then you come up with a premium. Okay? And the premium has to be in dollars. So you're going to come up with a percentage times the notional amount, and that's going to tell you what the dollars amount is. Okay? Because the Blackscholes will give you like a rate. What is the actual rate that you will pay for the differential between S and X? That's your future price. And then you will apply that times the notional amount to come up with an actual dollar amount profit, how much you have to pay. Okay? That's what I'm going to say about that. So that's probably, you guys study a little more on that, and the other ones are pretty straightforward. Okay? And then any questions on that? I know you might have questions on that specifically. We're not trying to be vague about it, but I want you to start thinking Blackscholes. I lock in a future rate. I have today's spot price. I know what the rate is today. I'm locking the future rate. And that's the same thing, S and X, right? And you calculate what the rate you should pay now to get the appropriate rate to actually hit that future rate. And then the notional amount multiplied by that. Okay, there's a lot of examples in the book, so you can follow some of the book examples. You can use mine. I have one example on my Excel sheet. This is question 9 of the final exam.